Hi, this is LindsayPrigmore. This is my final project presentation for CIT260. I'm going to start with explaining the difference between static and non-static methods. A static method belongs to the class itself and not, and a non-static, which is also an instance method, belongs to each object that is generated from that class. So if your method does something that doesn't depend on the individual characteristics of its class, you want to make it static. Otherwise, it should be a non-static. Or in other words, if there is any method that wants to be executed multiple times, this can be declared as non-static. And if there's any method that wants to be executed only once in the program, then that can be declared as static. Here are some static examples, a list of static examples that where each method is only going to be executed just once. So both an array and an array list are used to store elements, which can be either primitive or objects in case of an array list. An array, though it's static in size, it has a fixed length data structure. So basically, you can't change the length after creating an array object. An array list is dynamic in size, though each array list object has instance variable capacity, which shows the size of the array list. So as elements are added to an array list, its capacity grows automatically. Here in our map, so we used an array for our map. It's a 6x6 array. Also notice how the array is static, as I mentioned before. And we used an array for our map because we don't want our map to be growing or extending. It's a static in size. It has a fixed length, and it's perfect for our game. And there's also an enum, which you cannot assign any value other than what's specified in an enum constants. Here in our location enum right here, I have a simple example of an enum where if you'll notice on line 14, the enum keyword, which is used in place of a class or interface, the Java enum keyword signals to the Java compiler that this type definition is an enum, and just gives that list for us, which we can use here as a string list. For a for loop, it executes a sequence of statements multiple times. It's useful when you know how many times a task is to be repeated. So we go here. You can iterate using for loops, which is what we did here. Starting on line 28, it's going to run through each variable and run through the code each time until it ends. And here we have our exception classes. An exception class is created for each control layer class or for a group of control layer classes that are related. We created this new exception class here, the win game exception, and we created overloaded constructor functions that allow you to associate a message and cause to the exception object. Now, we implemented the exception using a throw catch code, and this was something new for me that I've never heard of, and it was really interesting. So you throw an object and catch it. So let's see, we'll see simulation control here. So here you can see the win game exception is being thrown. On line 57, we replace the statements that returns the error code value to signal an error with a statement to create and throw a new object instance of this win game exception control class that we created. We used the overloaded constructor function that then is going to allow us to pass in the error message to be associated with the error. Now, just like in real life, you can't just throw something at nothing. You need to throw something that will catch it. So we need to add catch statements to these functions. It's going to catch and handle any runtime exception objects that are thrown. Now, I'll show you where we catch this. It's being thrown and it is being caught. So if we go up one more here to the main menu view, you'll see right here is it's catching what we just threw. And on line 68. In the catch clause, we also print the error message associated with the exception object. So in this case, if they do win the game, it's going to congratulate them. So I'm going to explain why and when a character stream class should be used versus a byte stream class. A stream is a way of accessing a file. So a byte stream accesses the file byte by byte. A byte stream is suitable for any kind of file, however, not quite appropriate for text files. For example, if the file is using a Unicode encoding and the character is represented with 2 bytes, the byte stream will treat these separately, and you will need to do the conversion yourself. A character stream will read a file character by character. A character stream needs to be given the file's encoding in order to work properly. Character streams are tied to data type, so only string type or character type can be read through it, while byte streams are not tied to any data type. Data of any data type can be read except string, just you have to specify it. You should not use byte stream to read character stream. And now to write character data to an external file, you need to use outFile. This means that your outputting is getting sent to the file specified and not to the console. So our game is working and running, and it's a game where it's called Cluna, where you are in the specific location, which in our case is a completely new planet, and they have the 6x6 map that they can travel on. And if they go off the map, we made an exception for that will warn them they're going off the map. And they have to completely create a cure for this disease that's going around, and they have to find a lot of scientific material that will help them create this cure. And so they have a certain time for their game before it will run out, and if it runs out, then they will lose and they'll have to start over if they don't create the cure in time. So it was a fun game and a really awesome semester. I learned so much, and I'm grateful for the information that I've gained so far, and hopefully I can implement it into my future careers. So that is my final presentation, and thank you for watching, and thanks for your time this semester as well. Bye.